Welcome to lecture series on database management system. In today's lecture series, we will discuss about functional dependency in DBMS. So the definition says that functional dependency is considered as a constraint. This constraint helps in identifying the relationship between a pair of attributes in a given relation or in a given table. So if there are, as you already know, a relation contains set of attributes. So functional dependency is all about identifying the relationship between those set of attributes. So functional dependency is also used for defining the various normal forms of a given relation. So it alone it cannot be used. Along with candidate key and super key, functional dependency can be used for defining a first normal form, second normal form, third normal form, and BCNF in a given relation. So here is an example for a functional dependency. We are given a relational schema which contains attributes from A1 to AN, and X and Y are considered as a subset of given relation. We can write the dependency as X determines Y. If we can write a dependency like that, we can also write as T1 of X is equal to T2 of X, and T1 of Y is equal to T2 of Y for any given relation. Given relational instance R of R. So the attribute set on the left side of the arrow is called as, if you take this functional dependency X tends to Y, the attribute set on the left side of the arrow X is called as a determinant, and the attribute on the right side of the arrow Y is called as the dependent attribute. So here X is considered a set of, X can be a single attribute or it can be one or more attributes. So X is a set of attributes which is capable of determining the value of a single attribute Y or one or more attributes of Y. So here are a few of the examples for functional dependency. If student ID can determine the attribute student name and birth date. From the student ID, we can determine the student name and birth date. For example, if in a class, consider class as a relation or a table. There are a list of students and each student will have his own student ID or the roll number, and each student will have his name and his birth of date. So if I am calling out roll number 15, then I should be able to identify the name of that particular roll number as well as the date of birth of that particular roll number. So we can write the functional dependency as student ID determines student name and birth date. So here the determinant is one single attribute student ID, whereas the dependent is combination of two attributes student name and birth date. So let us consider one more example. Sports name can identify the type of sport. For example, if I am mentioning the sports name as chess, I can say like chess is an indoor game. So the type of sport here is indoor game. So we can write the functional dependency as sports name determines the type of the attribute. So one more example is student ID and sport name determines the hours per week that the student practices his sports. So here two attributes, student ID and sport name together determines the hours a student is practicing per week. So student ID and sports name together will determine the number of hours the students is practicing per week. So here we have two determinant attributes like student ID and sports name. So student ID along with the sports name will determine the number of hours. So functional dependency is a we can also define functional dependency is the property of attribute in a given relation R. So if there is a key L in any given relation R, then this particular key should be able to determine all the attributes of that particular relation. So we can under functional dependency, we have several rules such as reflexivity rule, augmentation rule, and transitivity rule. These rules helps in identifying the Armstrong axioms of functional dependency. And there are several types of functional dependencies such as trivial functional dependency, non-trivial functional dependency, a multi-value dependency, and transitive dependency. So trivial functional dependency is that if there is any relation such as A determines B, then B should be a proper subset of the attribute A. That is called as trivial functional dependency. So multi-value dependency is that if one determinant attribute determines more than two dependent attributes, or more than one dependent attributes is functionally dependent on one determinant attribute, then we call that functional dependency as multi-valued functional dependency. So next is non-trivial functional dependency. So non-trivial functional dependency is that uh, the dependent is strictly not a subset of determinant. If the determinant is not dependent is strictly not a subset of determinant, then it is non-trivial functional dependency. So it is quite the opposite of trivial functional dependency, where if there is a dependency called as A determines B, then B should be proper subset of A. Whereas in case of non-trivial, B is not a proper subset of A. So this is non-trivial functional dependency. So one example for non-trivial functional dependency is roll number and name determines age. So here age is not dependent on roll number and age. I mean roll number and name. So given a roll number and name, I cannot say this particular roll number will have only this particular age. So I cannot say like that. So here age is a dependent attribute which is not a subset of roll number and name. So this is example for non-trivial functional dependency. On the other hand, consider one example like course code determines course name. So here course code is determinant attribute and course name is dependent attribute. Obviously, one particular course code will have only one course allocated to it. So course name is fully dependent on course code, or we can say like course name is a subset of course code. So this is example for trivial functional dependency. And the last one is the transitive dependency. In transitive dependency, dependent variable is indirectly dependent on determinant. For example, consider two functional dependencies, A determines C and B determines C. So when A determines B and B determines C, then according to transitive functional dependency, we can say like A determines C. So here C is a dependent attribute which is indirectly dependent on the determinant attribute A. So example for transitive functional dependencies, consider two dependencies. Roll number determines department and department determines the building number. So from these two functional dependencies, I can arrive at the conclusion building number is dependent on enrollment number. So if I'm given the enrollment number, I should be able to identify the building number where the course is happening. So this is example for transitive functional dependencies. So these four are the various types of functional dependencies. So in this lecture, we have seen what is functional dependency. We have seen few example for functional dependencies. I have also described about the properties of functional dependency, such as trivial property, reflexivity property, augmentation property, and so on. We have also seen the types of functional dependencies such as multi-value dependency, transitive dependency, trivial and non-trivial dependency. So in the next lecture, we will discuss about Armstrong axioms. Thanks for watching.